But tonight I have a very special honor, and that is to introduce Dr. Martin Nweeia. Extraordinary is the word most often used to describe the Arctic marine mammal narwhal. Inspiring the legend of the unicorn, the adult narwhal, which may weigh about 1,600 pounds, be 15 feet long, and have a tusk of 7.5 feet or longer. It is possibly the most fascinating tooth organ system on the planet. The tusk erupts in the upper jaw and protrudes through the lip. Once you understand how unusual and magnificent the narwhal and its extraordinary tusk are, you'll better understand what a country dentist from Sharon, Connecticut, has traveled 2,500 miles due north to study the narwhal. Our keynote speaker this evening is a clinical instructor in the school's Department of Restorative Dentistry and Biomaterial Sciences and principal investigator of narwhal tusk research. Not only is he a dentist, but he is an explorer, a national fellow of the Explorers Club, as well as a graduate research fellow in the Department of Anthropology at the Smithsonian Institution. He has led a team on 12 high Arctic expeditions and a 15-year study which resulted in the discovery of sensory function and anatomic classification for the narwhal tusk. When you get a chance and leave this room, there's the tusk on the side of the wall that was donated by someone in Connecticut, I think. I am pleased and take great pride in presenting to you our own Dr. Martin T. Nweeia. Martin.
2 months ago, I was called by the producer of NPR's A Beautiful World. And she asked me, would you mind being a part of an interview on seismic testing that we're going to be running a story on? I'm a dentist. I've done more things with the tooth than sound production, but I agreed to do it with the caveat saying I can offer aspects of anatomy, evolutionary biology, but not much on sound. Now, for those of you that don't know much about seismic testing, this is more or less what a research vessel would look like. They deploy typically 3 or 4 air guns that produce 250 decibels of sound. Most of you in this audience probably understand what that volume is, but for those of you that don't, just to get some statistics about it, if you remember going to a football game or a hockey game and someone with one of those air horns was in the audience, those produce about 130 decibels. If you're about 100 feet away from a thrusting jet engine, that produces roughly 150 decibels. Now at 90 decibels, you do irreparable damage to your hearing. So let's think about 750 to 1,000 decibels in the ocean. The purpose of it is to map out the ocean floor and see where there are reserves such as natural gas and oil. But having talked to the other person who was being interviewed in this same story, Chris Clark, who's in the bioacoustics laboratory at Cornell, he said these seismic testing arrays can be recorded 5,000 miles away. Now, if they can be recorded 5,000 miles away, I can only imagine what they sound like 100 miles away, and 10 miles away, and in the immediate vicinity where you as a whale might be swimming. Now, the area that was being immediately affected in the high Arctic was a region of Clyde River on the top portion there. This is about halfway up Baffin Island. The research that we typically do is about 100 to 200 nautical miles due north. And a gentleman by the name of Jerry Natadine, who was the mayor of Clyde River, and a group of his citizens protested in the court system of Canada. And in 2015, they brought a case that was denied by the court system. And once it's denied, you have less than a 10% chance of getting considered in any other court matter. But in this case, they applied to the Supreme Court of Canada. And in 2016, that 10% became 100%. They got heard, and as little as 2 weeks ago, they actually won the case. Now, the case basically involves only delaying seismic testing for 1 year until you can prove harm or damage to the environment. Now, all of us with gray matter between our ears understand it's pretty likely you're doing harm. The work that I'm involved with, this is in Pond Inlet, which I mentioned was about 200 nautical miles north. We're in 36-degree water here doing physiologic testing. I've done this for about the past 15 years, and hands-on, these are live captured whales that we work on for roughly 30 to 40 minutes and then let go. And the areas that we typically work in, these are the 2 expedition sites, although we've worked in roughly about 10 different regions. These are the most common ones. The one in Tremblay Sound is the one that I mentioned was about a couple of hundred miles away, and then in Kakiak Point, actually more of a distance away. But the reason why I mention this is because in 2008, something a little unusual happened, and it's called a savassit. And what that means is that narwhals are trapped because of what's called fast ice formation. For unexplained reasons in the Arctic, there can be dramatic changes in weather that cause fast ice to form. Normally, these whales can predict ice formation, can get out of the inlets that they swim into in the summer months, but in the case of fast ice, they get trapped. Although this looks like a dramatic photo from an aesthetic sense and looking at the tusks, these are whales that are probably not overly happy because they're being a little crowded by ice. And when this crowding happens, the last one really that was large was in 1915 in Greenland, and about 2,000 whales were killed, or harvested is probably the nicer word to use. And in 2008, roughly 823 whales were harvested. Now, the interesting aspect about it was scientists and Inuit elders and hunters agreed that the population of narwhals that were in this region 200 miles away were from Clyde River. And that's interesting, because if the seismic testing was going on in Clyde River and caused whales to migrate 200 miles north and be caught in a predicament that they normally would not be caught in, it's something we have to take note of. Savassits typically occur maybe once every 50 to 100 years. In the last 10 years, there's been 8 that are documented because of climate change. So much of the work that I've been doing, in addition to the physiologic work, is also working with traditional knowledge and understanding, as my beautiful wife, who's an environmental economist, talks about, listening to the language of Mother Earth. And when you listen to the language of Mother Earth, as most of these indigenous populations do, you come up with very different observations. For those of you that remember, in 2004, there was a large earthquake and tsunami that ensued in the Pacific. The rubbing of 2 tectonic plates, roughly 600 miles in width, producing enough energy at the equivalent of 23,000 Hiroshima bombs, causing an insurmountable tidal wave that caused destruction roughly in the neighborhood of 250,000 deaths. The tidal wave was so strong that it hit even parts of Africa 3,000 miles away and caused deaths there as well. Interestingly enough, the only people that survived were the Moken people, commonly called the Sea Gypsies. They were able to read the water. And though a wave like this had not occurred for almost 100 years, there was one elder that was taught by his grandfather how to read the ocean when a tsunami was going to come. Alerted all the other island populations, they got into their boats a day in advance and went out to sea. Also, if we're going to listen to things, we have to understand that we listen to the animals as well. If those of you that remember, there was some press about a British couple who was on an elephant. And the elephant started rampaging up a mountain, and they were frightened out of their minds because they didn't know what was going on. They were part of a tour, and little did they know that the elephant would save their life. Elephants have an ability to read the vibrations before an earthquake happens. Now, to give you an idea about some of this type of knowledge, in Guangxi province in China, seismologists estimate that snakes are the most sensitive to these vibrations. Snakes, they estimate, can detect an earthquake 5 days before it happens. if they monitor other earthquakes in other regions. There's been ones in Seattle where cats mysteriously have issues. The one in Thailand, very few animals were killed in that circumstance. This is another type of example. Oh, I actually wanted to bring one more example just to show you that it doesn't take a sophisticated scientist to figure all this out. In 1755, Immanuel Kant, the famed philosopher, observed in southeastern Spain thousands of earthworms coming up from the ground. 8 days later, there was a devastating earthquake in Portugal. It's what you're listening to. It's what you're attuned to. It's not the big machines. It's not the early warning systems in the weather. It's how you relate to the planet. This is one of my favorite examples that was told to me by my program officer at the National Science Foundation. Jerry Ward, who was the senator of Alaska in the 1940s, was Inupiaq, the native indigenous people of Alaska. And Jerry had a particularly not so likable relationship with fish and wildlife folks. And there were two fish and wildlife scientists that did a study for 2 years and were very happy to announce the purpose and the function for the Nweeia River. This is the Nweeia River. It runs through the high northwestern part of Alaska. So proud were they that they made an appointment with Jerry and in his chamber said, "Sir, we believe we have found the reasoning for the Nweeia River, the main function it serves in Alaska." And not to be too easily impressed, he looked at them and said, "That's very interesting, gentlemen. What'd you find?" And they said, "We think it's the primary breeding ground for dog salmon." And Mr. Ward looked down for a moment, then looked up, and he said, "Do either of you by chance happen to know what the Inupiaq word Nweeia means?" And they looked at each other, looked back at the senator. He said, "It means primary breeding ground for dog salmon." Thank you very much for your study. So in 2011, this is as a date of 2012, but 2011, I organized a panel that dealt with a very different aspect of science. Traditionally, we all are results-oriented. We want to know, what did you find? What did you discover? How did it, where was it? All the different facts around it. But very few people focus on how. Very few people focus on the methods. How did you do something? And the how in traditional knowledge research is critical. Because how you approach people and how you support them and how you in turn give back to a society after you do your research is really the hallmark of great research. So what I decided to do was create a panel. It was a full-day panel at the Smithsonian where I invited a panel of people from all over the world, institutions, to tell us how they did their work. And it was so widely accepted and received that I got most of the speakers with the most notoriety, if you will. And because it's such a small community, everyone was wondering, gee, why are they all going to that session, And the reasoning they had was because it resonated to them that someone was concerned about how things were being done, not what the results were. This is a photograph of a gentleman by the name of Charlie Unarak, who came up to join us in a 2016 Arctic Crashes Symposium at the Smithsonian. And Charlie was there again to make comments, not necessarily about the Arctic crashes that might be going on with some of the marine mammal life, but about how this affected their community, how it affected their population, what climate change looked like from a kayak, not from a satellite. And these were the kinds of ways that we intercede our research with scientific research so that there's some kind of junction and people understand. About 5 years ago, I was doing anatomical plates for the narwhal, and I decided we can't do this with scientists. So we brought an elder and a hunter. We had probably the foremost evolutionary whale biologist on the planet and a whale anatomist who's also very renowned. And together with two artists, we did some of the renditions that we did. And this is the kind of collaboration that we foster. The NSF study that I received through this institution was basically trying to link traditional knowledge and how it affects this extraordinary animal. And most of the direction that we received in science came from traditional knowledge. We were interested to find, for example, behavior. Animals with the largest tusks, typically males, lead the group. Adolescent whales typically are flanking the sides, keeping the general herd of these whales, which can be in the thousands when they're migrating, in line. All these kinds of aspects were informative to us. And likewise, in their legends, in their lore, this was from the Inuit legend of the Narwhal, which basically talks about a woman who abuses her partially blind son. And what was interesting about this legend is I had heard it about 10 times, and I was reminded of something that Albert Einstein once said. He said, any fool can know something. The brilliant man he actually said the brilliant person, I should correct that. The brilliant person understands. I had heard this 10 times, thought I knew the legend, and I had brought 2 hunters to an Inuit Studies conference in Paris. And on the last night, both of these gentlemen got incredibly drunk. There was more beer in the room than the room. And when I sat down to visit them, I knew to arrive late because I would never be able to keep pace with any of the people in that. I sat down, and moments before, I had asked the elder who came with us, can you tell me your rendition of the Inuit legend? He said, I don't know it. And he just kind of brushed it off. And I sat on the bed, and then the hunter, they were mumbling something, and he said, he wants to tell you the Inuit legend. And I thought, geez, I thought he didn't know it. So he told it in incredible detail, and for the first time, I actually understood the legend. And it was, kind of our equivalent of a golden rule in Inuit culture. It's quite deep and involved, so I'm not going to go into it here. But the point really is this discernment between hearing and listening and understanding. We're currently involved in a large genetic study. This is a collaboration with the Broad Institute. That's a partnership between MIT and Harvard. We're with the Global Genome Initiative at the Smithsonian, and also doing with the Global Genome Legacy Project out of Northeastern University. Several institutions around the world involved. We have already sequenced and assembled the female narwhal genome. We're doing the male genome, and then we're having a team of people that can somehow make an association between this work and other tusked animals and perhaps humans, because we're kind of fascinated with questions that we don't really understand. The animal has the potential to grow 16 pairs of teeth. It genetically silences almost all of those teeth, except for the tusks. Why? Especially if you're eating fish and you've got no teeth in your mouth. Who thought that was a good idea? So we need this genetic insight to figure out why. Now, I think of the words of Buckminster Fuller here, because he said, if you want to change things, you can't fight the existing reality. To make a change, you have to build a new model and show that the old model is obsolete. So that's exactly where I am in this work with traditional knowledge now. For those of you familiar with the Russian TRIZ system in knowledge, or those of you who might know things about mind maps, I decided that none of these systems fit. So I decided to build a three-dimensional model and just call it a 3D knowledge model. But what I found was that there was an incredible disparate difference between how science interpreted the world and how traditional knowledge interpreted the world. And nobody really wanted to listen to each other. They all kind of discounted each other. Scientists would say, geez, one guy said it, so where's the reproductive validity in that? You got a sample size of 1. And the traditional knowledge people would say, geez, the scientists come up here 2 weeks and they think they know the whole environment. Even if you take all the samples in the world, you can still be wrong. So to try to merge these two was eventually the goal. And I think throughout all of this work and all of the understanding, because I was privileged enough to be invited to go to the National Science Foundation and give a lecture. And they thought, and I came there during a snowstorm, which always cracks me up in Washington, D.C., because that's about 5 snowflakes. So I drove down from Connecticut to be there. I had not a clue that that was considered a snowstorm. So I got there as the speaker. They apologized to me when I got there, and they said, we're not sure how many people are going to show up. Well, anyway, everyone came. And they had to start taking chairs from the outside hallway. They had to figure out where to put people. And all of the people organizing this thing said, we've never seen this at the National Science Foundation. All these people hide in rooms. It got to be so large that they decided to have everybody introduce themselves because half the people in the room didn't even know who they were working with. But what was interesting and what happened to me after that talk was 3 people took me out to lunch and they said, we think you should direct a large collaborative grant between 1 and 2 million. And I was just trying to keep a straight face there. I'm just I'm a dentist. I'm just doing this to have fun and, learn about something that fascinates me. But I realized that the obvious is not so obvious to people. That by just talking to your neighbor, by just talking to the people who live with things, it's the most obvious thing to do. Why does science have such a hard time with this? Sometimes when they actually consider the traditional knowledge, it's as a footnote. Or, when we did the article with the Smithsonian, we were the first people to acknowledge the Inuit elders and hunters as full authors, even though ethically you weren't supposed to do that unless they were involved with writing the article or having some hands-on approach to some section of it. But I hope the voice today is the voice for them to speak to you and say, there is value, and this is the place we need to rely on for the future of some of our knowledge. Thank you. Climate change is real. It's so real that the scientists, we're organizing an exhibit at the Smithsonian now that's going to be up in 2017, and certainly all of you will be invited to that. But the scientists there feel so strongly about it that not only are they saying it's real, but that it indeed is induced by a human factor. Now, that was the part that was always the shady thing. The Smithsonian as an institution, that's a given for them. And these are the leading scientists around the world, people that study this. I'm not a climate person, so I'm not going to speak to that, but I can relate to the stories that other people have told me.
Well, you've told me that the ice where the Inuits live is very different, that their patterns of living have changed.
Absolutely. Yeah, and so dramatic, in fact, that we went to one community, it was called Resolute Bay, it was further south. They had seen narwhals for 13 years, and the year we went up there, none. We went up to Pond Inlet last year. There was ice entrapments all over the place. So things are dynamically changing. Obviously, people who study this have a better aerial view of this whole thing than we do as scientists that are a little bit more immediately attached, but certainly a lot of abrupt changes are going on. 2 questions, I'll answer the first one first. The tusk is primarily dentin. It has an inner core with a pulp and a nerve, no enamel, but it's distinguished by other tusks in having a cementum coating running the full distance of the tusk. So unlike walrus or elephant, for example, where the dentin would be the exposed surface, in this marine mammal, cementum goes completely out almost to the end of the tip. To answer your second question, do they impale each other? Interestingly enough, there was a study by a lady whose name is Helen Gerson. It's Helen Silverman now. The names have changed. But she did a study in Nature that was published showing that there were indeed these fights between animals, and also showing that impalement, if you will, was a reality. I must tell you that I doubt some of this. I don't doubt it exclusively. I don't say that it doesn't exist. But I doubt that's a normal course of how this whale interacts with other tusked whales. This sensory organ is too valuable for this animal to want to compromise and run the risk of breaking. In her study, for example, which I did a very careful analysis, again, listening to the words of Buckminster Fuller, if you're going to show that the other reality, you want to show it obsolete, you have to be able to somehow prove that someone's existing study is wrong in a sense. But anyway, I looked at the reports of 35% fractures that she had cited in her paper and know and understand that she got them from museum specimens, which typically get the worst stuff. It's very expensive to buy an intact tusk, and museums typically can't afford that, so their specimens are already skewed to be broken. The other aspect was showing, the impalement, the scarring on the head, which she also reported was quite high. I have to tell you, after doing 15 years of this, seeing thousands of whales, I have no idea what she was talking about. So I actually called her up on the phone and I said, I see in your, materials and methods section that you have a series of photographs. Would you mind just sending me your photographs? And, she said, I don't have them. And I thought, geez, if I was a scientist and I had a Nature paper, I'd be sitting on my results. But there has to be accountability in research. I mean, we've talked about this. I've talked about this with the National Science Foundation as well. There has to be some kind of repository for results so other scientists coming in can see things and understand what they are, especially if you get federal funding. Well, the first thing is we're a dental school, so we're going to call it a tooth. A horn is very different embryologically in almost every way. The primary function of this, as we have discovered, and has been a new aspect of the research, is to show that it's a sensory organ system. That is a first. Everyone else before us has tried to show that it's related to other aspects, like the mating rituals, showing the hierarchy. And those could indeed be true. As we all know in this audience, teeth can be multifunctional. There's no problem with that. So when we came out with our study and our results, we were very careful not to say this is what it is and this is what it isn't. It was just to say this is a new body of information to consider with all the other things that have been out there. In terms of the black market issue, definitely a black market issue. If you were aware, there was a whole scandal that broke about a year ago in the state of Maine where they had a cargo system underneath a truck where they would house these. And they were discovered, and I always wondered, because whenever I came over the border, after the 9/11 whole incident, my world changed, in terms of doing research. So everything was investigated. But certainly that trade in those, I believe in Asia is still existing and is legal. Within Canada, it's legal. Within the United States, obviously, it's not legal unless you have a tusk that predates the 1970s when the Marine Mammal Act came into vogue. And then Europe has also banned them as well. So a lot of countries around the world have joined forces to not create a market, so you're killing an animal necessarily for a tusk, and nor do we feel that the Inuit should be penalized for actually the food sources that they get that are very valuable based on the habits of other people around the world. They can't. They get stuck. And it's always interesting to me because there's always someone who's got some knowledge base that comes up to me afterwards and they say, well, if it has such a great sensory system, how did they get caught in the ice? And I always respond to them by saying, if we have such great weather detection systems, how does Katrina happen? So every animal has its limits. But certainly they have the ability to detect, as we reported in our 2014 publication, salt gradients. And salt is a direct relationship to ice formation because obviously the more fresh water that leaches out to form ice, the higher the concentration of the salt remaining. So that's a warning sign for them to get out. It will not grow back.
No, it will not.
It will not.
Oh, okay.
Nope. Yeah, I mean, elephants and walrus have a little bit more of that ability, but not narwhal. It will not grow back.
But then it needs a root canal.
It does. We actually have a group in California that is part of our collaborative effort that is cloning this tissue, but for a very separate issue, and that is that the narwhal tusk is very unique in the sense that it has high strength and high flexibility, properties that usually don't coexist in the same tissue. So we're cloning that as a system to explore the ideas of biomimicry and how that might be used. That's an interesting question on a couple of different levels. First of all, it's most characteristic to be on the left side. There are a very small incidence, and again, this is a guesstimate. 1.5% in some literature has shown that whales can have two tusks. So they can have a tusk on the right side, but interestingly enough, they defy the evolutionary property of mirror image symmetry, because if they do form on the right side, they also have this left-handed spiral. They do not have a right-handed mirror image spiral, as in every other mammalian species. And likewise, the size difference is also characteristic. So typically, the right side tusk is slightly shorter than the left. Yeah, I don't know. We are exploring this on a little different level. There was a paper by a gentleman named Kinsley in England who was reporting that, because it's the only straight tusk. So to form it straight, supposedly you needed the spiral formation to keep it on a straight axis. I don't know if that's just defining something backwards. You know what I mean? I'm not so sure that that's the definitive result. Other aspects like strength, how spirals are associated that way. I've talked to hydrodynamic people who say, if you have a straight surface, you form multiple vortices of water when you're swimming through, as opposed to a spiral, which typically has 2 vortices, so there's less drag on the tusk. All these things are kind of out there, but I don't think anybody really knows. There's huge impact. Not necessarily just from the Russians. Everyone wants a piece of the Arctic. For those of you who know, it's an incredibly resource-rich part of the world. When we talk about millions and hundreds of millions of barrels of oil, for example, in the Middle East, we're talking about trillions of barrels in the Arctic. It drastically and dramatically dwarfs any other region in the world. Now that there's climate change and there's access through the waterways there are many more boats. Since I started about 15 years ago, maybe 1 or 2 boats, and I'm talking large cruise boat type boats, would be up there in a typical summer. Now you can find 15 to 20 easily, and that will proportionally get larger. That, coupled with the seismic testing and all the impacts there, it's going to have a dramatic effect on the lifestyle of these people. Yep.
Martin, thank you so much for a fascinating report.
Oh, thank you.
Congrats to present. That's for an explorer of the world.
Thank you, sir.
Thank you very much.
Yeah, thank you very much.
Thank you.
Yeah.
And everybody's invited to dinner.